Hello, my name is Dr. Kuka, and in this video we're going to be continuing the Tetrazole experiment. So we just heated one of the nitriles with sodium azide in the microwave reactor for about 30 minutes and at about 160 degrees. And we allow that reaction to cool, and then we took off the cap from the reaction vessel. And at this point, we want to do a TLC of our product and compare that to the starting nitrile. So we want to place about 10 milligrams of the nitrile in a small beaker, dissolve it in a few milliliters of ethyl acetate. That's going to be our standard solution for the nitrile. We want to grab a spotter, so just a glass capillary open on both ends. Dip that capillary into our standard solution like so, and then by capillary action, some of the liquid in that solution will move up the capillary, and then we can transfer that into a TLC plate. So here's an example of a TLC plate. So a TLC plate is maybe a couple of inches tall and one across. And we want to use a pencil to make an origin mark. So that line that you see going across at the bottom here is our origin. In one spot, I placed the letter N. In the other spot, I placed the letter R. So N for nitrile, R for the reaction. So with our TLC spotter, we can now touch our TLC plate. TLC plates will have silica coating or alumina coating on one side, and then the other side will either be a plastic or aluminum sheet. In this case, is a plastic backing. So when we touch our capillary that contains a little bit of the nitrile, it'll transfer that into our TLC plate on the silica, and then we want to take our capillary and either clean it or grab a new one. So you can clean these capillaries by touching a beaker full of acetone and then touching a paper towel and back and forth a few times, and it should clean the capillary to be reused, and we can reuse it at that point for a different solution. So in this case, we want to test our tetrazole reaction. And so we will grab the same capillary after we clean it, dip it in the solution, and that again by capillary action will pull some of the solution into our capillary. We would touch now the origin line where I placed an R, and that would be where our reaction is. I placed this TLC plate that had both the nitrile and the tetrazole in two different lanes into this development chamber. So it's simply a beaker with a filter paper and about maybe 3 mLs of ethyl acetate in it. I will place it inside, lean against one of the walls of the beaker, and cover the development chamber with a watch glass. If I do that, the solvent will move up the TLC plate, so I'm going to be placing the TLC plate with the origin facing down. The solvent will creep up to the TLC plate, and when it starts to reach the top, I want to pull that TLC plate out before it reaches the very top, and then I want to mark the solvent front. So we get a closer look here at the top. Here you'll see a line across. That's the solvent front. So I already previously let this TLC plate run, so that's why it's already marked up. And then the next point, or the next part, would be to now take our TLC plate that has been developed in the development chamber and go under a UV light like this one. So the UV light typically will have a wavelength of 254 nanometers. If I place our TLC plate underneath it, you'll see that the TLC plate glows a green color. If it has an indicator, and the TLC plates we buy will have an indicator on them. And any spot that is on there will show up as a dark blue color. So I marked the TLC plate where those spots are. I drew a circle, and so now I know where my spots are. And so this is the result that we get from this TLC plate. So on one side we have R here, and you can see that there's a spot right around there, which is a little bit lower than the nitrile spot. So this is where I spotted originally the nitrile. It went up once it was developed, and the spot for the nitrile is a little bit higher. And you can clearly see that the nitrile and the reaction spot are not the same RF, so they're not the same thing. Important to note is also that there is no spot for a nitrile, or where the nitrile normally is. So that's a sign that all of the nitrile has completely reacted into something new. We no longer have any unreacted nitrile. And in some cases, for this particular experiment, you're going to sometimes see a spot for the nitrile, which means you still have some unreacted nitrile left over.